An 8th-level mechanic at a repair shop in Pakistan decided to make new dies using truck leaf spring steel to keep their thread dies functional. With simple lathe work, they could create durable and rugged thread-cutting dies. In Peshawar, where resources are scarce, even damaged dies are intricate to replace. To avoid interrupting the shop's daily work, the mechanic replicated the die using steel plates of consistent thickness. However, since the steel of the truck's rear axle is challenging, the plate had to be annealed by heating it to reduce the hardness before machining. This annealing involved heating the steel until red hot. The truck's suspension steel plate was also bent, so to ensure the bend wouldn't interfere with the machining process, the heated plate was straightened using a hydraulic press. The slight bend was quickly flattened, making the steel plate ready for machining. The mechanic marked the steel based on the die's outer diameter to minimize lathe work. The remaining steel could be used to make a second die. After quickly cutting the steel with an angle grinder, the square plate was secured to the lathe using a round steel bar to keep it in place. Once the plate was fixed and rotated with the chuck, the lathe tool was used to shape it. As the mechanic gradually increased the cutting depth, the one square steel plate was swiftly machined into a round shape. The mechanic meticulously measured the dimensions using a micrometer to ensure the new die matched the original factory specs. Once confirmed, the sharp edges were chamfered, and the rough surface was smoothed before the die was secured back in the three-jaw chuck. The mechanic made the holes using a drill since the three-jaw chuck could only drill through the center, and the steel plate couldn't be offset. This was their go-to method under challenging conditions. A drill chuck was attached to the front of the drill, and once the bit was secured, the base could be moved axially to drill off-center holes. The mechanic marked the hole centers using a marker after securing the steel plate to the die to ensure precise drilling. With each center point marked, the drill bit had a clear starting position. With the steel plate annealed, the hole drilling was quick. The mechanic skillfully drilled through the 5 positioning holes. To align the holes perfectly with the marked lines, the mechanic enlarged the holes with a more significant bit, ensuring no deviation from the original die's hole positions, which serve as chip exits. After drilling, the hole edges had burrs, so the mechanic used a threading tool to smooth the surface, ensuring it was perfectly flat. A tapping hole was then drilled in the die center. The mechanic prevented the bit from wandering while enlarging the center hole with a more significant drill bit. However, the hole was still undersized, so the mechanic used a dull tool to further enlarge it to the required diameter based on the original die specs. The mechanic then carefully checked the measurements with calipers. In addition to the diameter, the interior needed to be threaded for tapping, so the mechanic made the initial marks. With expert lathe control, the mechanic quickly cut the internal threads, producing the precise thread pitch required, successfully replicating the broken die. Since the original die had an opening, the mechanic marked and cut the opening using an angle grinder and smoothed the edges, creating the required clamping gap for the die. Finally, the mechanic installed the die using the wrench's limit bolt, integrating it with the wrench. Despite the process being complete, there was an immediate need for tapping, and the newly made die was used to tap the rod. The thread cut was perfectly formed, confirming that the die met all functional requirements. If you were to rate the mechanic's skills on a scale of 1 to 10, what would you give them?